Alright guys, so any questions from that quiz? Yeah.
For the question that we didn't have the graph, we just had to tell what we knew, the one that had the x squared, I didn't know, because I factored out alpha 2.
I'm going to tell you something that you've seen is not related to the question, but what's the y-intercept here?
0. 3.
Negative 3. You're thinking ahead. What's the y-intercept here? 0. So if I have, what's the vertex here? 1, 0, because there's a 0 out here, right? What's the vertex here?
0, 7.
What's in with the x?
0.
Is there anything in with the x? No, so 0. 7.
So if it was 1/2 x squared, it'd still be the same.
Yeah, exactly. Yeah, it's all about what's in there with it. If there's nothing in there with it, then it must be 0. It hasn't been translated at all. Then, if there's no number in there with the x, I don't move it at all left or right. It's still at 0, but then it went up 7, so now it's at 0, 7. So this is how much it moves left or right. This is how much it moves up or down. It doesn't have to move up or down. It doesn't have to move left or right. No.
Is it safe bet that
I don't do any trick questions.
Is it safe bet that you would give us enough graph to see the entire interval?
I should have. You never know. I tried to ahead of time. But your scale might have to change sometimes. You know? You got like a vertex at 10, then you want to make it 2, 4, 6, 8, 10, or something like that. Yeah.
Can you give us the one that was the negative exponent?
Oh yeah.
Yeah, good one.
I mean, nobody had this problem, so that's cool. The funny thing is, if you wanted to, you could use that U substitution on both of those. You didn't really have to, though. Really.
Divide the whole thing by -1.
That would make it negative x negative 2 minus 5x negative 1 plus 24. That wouldn't really help you. I mean, powers can only be affected by other powers, right? Coefficients and stuff can be affected by multiplying, dividing, but I'd have to actually divide or multiply by x to a power. I can't do that. I can't do that to both sides. What you can do is just say, all right, this is just like x squared and x. Instead of putting xx, I'm going to put, and it's still the same thing about getting the numbers that go here. It's just that at the end, you're going to get like a number equal 8. X negative 1 equals 8, so x equals 20. If the flip of x is 8, x itself must be 1/8. Now that's supposed to. Yeah, we did one just like that in class.
Can I let u equal?
Yeah, oh yeah. If you wanted to, you could let u equal x negative 1, because then u squared is this. So that looks a lot better, right? It actually looks the same. But now at least there's no negative power. Okay.
Last question.
Alright, so 3a, something like this here. So 8.6 was where we learned about standard form. Now on number 3, I'll be a little lenient because officially we didn't talk about completing the square to put it in standard form until the next section. But we knew completing the square, we knew standard form. You could do both, right? We did one just like this before the quiz. How do I?
25.
Yeah, half of 10 is 5. Squared is plus 25, so better at the same time. Yeah. So I get x plus 5 squared minus 36. And then you could, that would be an ugly one to graph because it got a big ass vertex position, right? But still, you can tell me the vertex, you can tell me if it opens up or down, all that kind of stuff.
And would you say that the y-intercept would be?
You can see it from the beginning, remember? Here you can't see the y-intercept because the 0 doesn't make this piece go away. You have to actually work it out. But up here, 0, 0, you're left with -11. So what's the vertex here?
Negative y.
What was the shortcut we learned the other day?
It was negative b divided by 2a.
Negative e over 2a. So it'll be negative 10 over twice 1, negative 5. If you plug that back in, you'll get the y piece. You'll get negative 36. Right, you'll get 25 minus 50. Negative 25 minus 11 is negative 36. Alright, so that's a shortcut for it. This completed square wasn't really that evil because I put a 1 out here. So you didn't remember that whole, it's negative 2, I better add twice the thing, you know. It's just a straight up add, subtract. Okay. Doesn't make you feel any better if you messed it up, but.
So we have one more quiz?
No. I think that was our last quiz. Because the next thing, next week is going to be review, test, and then that's it. Which is crazy. It feels like yesterday we started.
No.
Oh, until I say all the people that I lost. What? I need to have like a in memoriam. Yeah. Memoriam, you have a.
There's no quiz next week. There's no quiz.
Yeah, that was the last one. So there's a test Tuesday. Who came in, didn't get the practice test yet? I think a few people had practice test. Who needs one of those? Comas, did you get it? Okay.
The test is chapter is 9 and 10.
Yeah, 10 is going to be something that we talk about. It won't really show up anywhere, but I must talk about it before you exit my class. So we're actually going to talk about 10 probably on the day of the final review. So there's not going to be any homework officially due. That's why I even have like little TBAs, I think, on the, because I wasn't sure if I was going to reach. I almost never reach that far. It's crazy. But I at least want to show you the forms of the equations and tell you what you can see from them. I keep saying like a circle equation, you can see the center and you can see the radius. So that's the two most important things about a circle is where is the center of it and how far do I go out from there to make it. If I know those two things, I know. So the equation shows you those two things because those are the two most important things. Like in a line, what's the two most important things? The y-intercept and which direction it goes from there. So that's why the equation of it has the slope, which is the direction of the y-intercept. Right? Okay?
I have a question for you.
Yeah.
This one in your lesson the other day, you put on the right side in positive, is that the 25?
So if we have, what are the two situations that people get mixed up? Why did I have to do plus 25 and minus 25? Why exactly? Because I'm doing everything on one side. Because I really don't have another side to work with. Now, you could do this and then subtract it at the end, but I just don't want you guys to do that. It's just bad form. What was the one where I could add and subtract at will? That's where I have an equation. That's where I have an actual other side to work with, right? So if I'm trying to solve an equation using completing the square like this, let's just do that one.
Hey, I have a question that's not on this subject, but after we get to final, how are we going to get our grades?
Well, then you can email me, or you can just wait until I get them posted to WebAdvisor.
Oh, you do WebAdvisor.
I have to. I mean,
Yeah, you have
if you
to
have
post it.
teachers that do like online grading sites,
Yeah.
where you can just see your grade throughout the semester, that's one thing. WebAdvisor is the thing that we must do because it's how we turn our grades in,
Yeah.
period.
Okay.
Yeah.
So we have to wait to find out if we
You can
pass the
email
class.
me that next day because I'll
Okay.
have them graded
Wow.
quickly because I want my tiny little summer to start quickly. So I'll have those finals graded pretty quick. So real quick, how do I solve this now using completed square?
Plus 25.
Divide 10 and
Yeah, so of course divide 10 by 2,
Yeah.
square that bad boy. This goes here, so if I put it there, I better
Subtract from the
do
other side.
careful now.
Add it.
If I add 25 to this side, I better add 25 to that side.
Whoa. Hold on.
All right, now.
But
Oh.
Because it's all on one side.
One side.
It's all on one side.
One second.
If I do everything to one side, then I have to add and subtract to make it cancel out. If I have two sides to work with, I've made it balanced because I have two sides. Whereas if I have only one scale, one thing, and I want to make it balanced, if I put something on, I better take something off. That's why I keep doing the dorky Indiana Jones thing, which a lot of you guys haven't seen. And then you keep going, x plus 5 squared equals 36, and that's a nice one because, right, I mean, this is how to finish it out, but I want to show you the two main things, and that's what gets people confused, and I understand that. Why do I subtract sometimes? Why do I add sometimes? Because here, I'm doing the same thing to both sides. Here, I'm not doing anything to one side, so this side by itself better balance. Well, shit, I added something, I better subtract it. So it balances itself out. Okay, cool. Yeah.
On this one, is there anything else you have to do after the x plus 5 squared minus 36? Is there anything you have to do? Like the other one, you did a square root.
Yeah, why here do I do more? Because this
Is an equal
is an
sign.
equation, yeah.
Right.
Whereas that one, I can't do anymore,
Okay.
really.
So there's nothing else you have to do on
It
that.
equals f of x, so there's no way I can solve for x. Yeah. Yeah, you can graph it from here, but you can't do anything algebraically to this, really. That's useful. Yeah. Okay. Any other questions from like the later sections we did? 8, 7, 8, 9.
Uh, 8, 9.
Yeah.
Number 12.
12. Okay, so the nice thing with those is there's even more of a visual answer than what we were doing in class. Because in class we made like a number line and we just investigated where's a positive, where's a negative. This guy is actually looking at the graph of the problem. So number 12, it gives you this here. And the first thing they do is they get it with 0 on that side. So they graph this. Now, what does that equation say? It's got to be true about that function.
It's got these two roots.
No. What does that inequality say must be true? What is it trying to say must be true about that function?
Everything on that side must be positive.
Yeah, well, this function must be positive in order for those x's to work. So it's saying what x's make this function positive or at least 0. Right? So when they give me that graph, let's see.
Negative 3, 0, 0, 0. And 2, 0.
Okay. And it goes, yeah. Like that. And real quick, do you see how some zeros it goes through? So it does change sign from positive to negative. And this 0, it touches and turns around. And we can see that. What would be the first step here if I try to do something by hand? What would be the first step? Pull out a x squared. So x squared would give me an answer of 0, right? If I pulled out an x squared, wouldn't that give me an answer of 0? In fact, let's go it all the way. This is not what they want you to do in the problem, by the way. This is just us kind of investigating this further. How do you factor that?
X plus 3.
And we actually know that already because that's where they got the 2 from. And that's where they got the negative 3 from, right? And that's where they got the 0 from. Now, what did we say the other day? What's the shortcut for knowing when the sign's going to change? If it's to an odd power, the sign changes from positive to negative or from negative to positive. If it's to an even power, it stays the same. So it's negative on this side, it's still negative on that side. You can see it in action there, right? So, how the hell do you answer this question then? We haven't done that yet, right? Keep going around the freaking answer. Where is this function at least 0? Couldn't you kind of like circle it on the graph? Where is at least 0?
0, 0.
Okay, I agree with you. So right there. back here, right? Isn't it at least 0 here?
Uh-huh.
And it's at least 0 there, right? So it'd be from negative infinity up to negative 3. Do you include negative 3?
Yes.
Yes, because it's equal to 0. Union with 0. Union with, get out of there, 2 to infinity. Why do I know it won't come back and change signs again? I mean, how do I don't know. I'm just looking here. I don't know what the hell it's going to do over there. Maybe it goes, wow. How do I know it's not going to do that? You're like, I don't know, man. You're a lot more math than me. You know, it's weird shit. Because the only place it can go change sign is where it goes through the x-axis. And I already see everywhere it goes through the x-axis. It can't possibly go through the x-axis any more places, or else it would have shown up as a 0. So it can do whatever the hell it wants to over here. All I care about is it's positive after that. And what it really does, it just goes up forever like that. On the ends, does it look like a parabola? And isn't the biggest power a fourth power? That should be like a parabola at the ends. In the middle, does weird shit because of these guys. Right? And in pre-calc, you're going to study the hell out of what I just said and make a big deal out of it. Right?
So much fun.
I know. Is it everybody good with that though?
Can
Yeah.
you explain the shortcut again, on like how you did the number line plus plus?
So if I did the number line here, let's pretend like we don't know that. So my zeros would be 0, negative 3, and 2. Right? And if we just kind of blindly did this, and I'll show you where the shortcut really would help. If I put in there like negative 4, that'd be positive, negative, negative. So overall, positive, negative, negative, so overall positive. Careful. Negative times negative is positive, right? If I put in there negative 1, everybody with me what I'm doing here?
Yeah.
I don't care about the number. All I care about is the sign. If you want to get the number, great. You just pull the sign off. A negative one would be positive, positive, negative, right? And that's negative. If I put in there a 1, that'll be positive, positive, negative. Right, did I do that right?
Yeah.
Positive, yeah, okay. And then if x is 3, it would be positive, 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 right? Plus, plus, plus. So it's going to be plus here. Is that what it does?
Yes.
It's up, down, still down, up. Right, above the ground, below the ground, right? If you want to look at it like that. So those negatives mean the outputs are negative. So certainly in here, the outputs are all negative except for 0 right at 0.
But didn't
And
you
out
say,
here, the outputs are all positive.
didn't you say there was a shortcut?
So
where
the
you
shortcut-
could add?
What's the only place where it doesn't change sign? Like what I mean by it is on one side it's positive, the other side negative. So I changed sign around negative 3, and that came from this guy, right? And he's to a first power. It changed sign around the 2, and he's to a first power. It did not change sign around the 0, did it? So that was the second power. So any even power will stay the same side on both sides, same sign on both sides, right? So the way I could have done this problem would be negative 3, 0, 2. Plug a 1 in, and I get positive, positive, negative. And then I go, okay, it's going to change signs there, it's going to stay the same there, it's going to change signs there, I'm done. A lot quicker than all this shit here, right? That's where the shortcut helps. Leaving you out from having to do all this mess here, right? If you don't like this shortcut, you can just do this. It doesn't take that long, really, to do this. Shortcut just helps you out with a little bit of time saving.
For the next math level, can you use a shortcut?
Oh, hell yeah, you're going to want to. Trust me. Yeah. You're going to want to. And those you're going to calculus, you're going to be doing the same idea on calculus idea. It's going to look the same thing. You're just going to be using different functions. But it's going to be the same process. Okay. Any other questions? Sorry, in that same section? Oh yeah. This one's kind of funny. first step here? What's your first step?
Factor.
Yeah, you gotta factor this thing out, right? How does this factor?
X plus 2.
Like that. Now stand back from that. Do you have to do any work? That's why they get the little aha on there. Normally that means there's a quicker way to do it, or it's similar to something we've done before, or something like that. What is this trying to say? If I square some real number, because here our whole thing here is real numbers, I get less than 0. Can that happen? No. So that's why they call this an aha problem. Now if you try to work it out, let's try to work it out. What would I put on my number line? Careful. -2. That's where it's 0. It's not going to change signs, but let's just forget about that for a second. If I put a 0 in there, what do I get? 0 plus 2 squared, positive. If I put a -1 in, yeah, that's good. -3 in there, I get -3 plus 2 is -1 squared is positive. It didn't change sign like we knew already it shouldn't. So how do I answer? It says, where is this negative? Where's the negative? Nowhere. So what's the answer? No solution. Cool. At least no real solution, right? And really, when we're talking about trying to graph things, we're talking about real graphs. We're not graphing complex stuff yet. Or we won't in this class.
I have a question.
Yeah.
It's from the review. Can I just read it's x cubed minus, is that it? X cubed minus 3x greater than 2x squared.
Okay.
And then I feel like we factored it right, but just want that over.
So was your very next step factoring, or what was your very next step?
Subtract 2x.
Ah, subtract 2x squared, yeah.
And then pull the x down.
Alright, pull the x out.
And factor.
And what'd you get here?
X minus 3x plus 1.
I like it. Cool, right? So process, get it to 0 on that side. Factor what you got here. Now you can see all the zeros. What are your zeros?
Let's see, 0, 3, and -1.
I like it. And the shortcut here would be nice. They're all to a first power, right? So they're going to change signs everywhere. So all I need is one region, and then they go crazy. It's negative, positive, or whatever. So, like, I'm going to put a 1 in there, maybe. That'll be positive, negative, positive. So we're overall negative, right? So what's this side going to be? Positive. What's this side going to be? Positive. What's this side going to be? Negative.
Yeah, I
Okay,
don't
cool.
understand that. The -1 and 0, because I looked at the back of the book and I got the 3 to infinity. I got that, and then it says -1 and 0.
Right there.
Continue to go over that at the end of the
Okay.
That, yeah.
You're cool with this so far, right? Now, if you don't like this shortcut, it might be an issue with the shortcut. I don't know, because that's what I just used. But you don't have to use a shortcut. You can plug a 4 in there. Positive, 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 right? Here you have to plug in what?
Or negative 1.
One -1/2, right? That would be negative. Negative 1/2 minus 3 is negative. Negative 1/2 plus 1 is positive. So overall positive. What's up?
Okay, okay. I get it. Sorry, I don't know why
No, it's
I was
okay.
thinking, no, that's negative when I did that.
Because this is a problem where we've never really just been totally focused on the sign. We always want a number answered. We all, as a student, we want number answers. We are getting number answers just a different way. We're saying this actually asks a question about the sign of this function. So if we knew the sign of the function everywhere, which now we do, we can go back and answer the question. It's positive in between there, and it's positive up there.
How would you rate that?
Oh yeah, so what would it be? Do I want to include -1?
Yes.
Do I want it to be
No,
equal to 0? No. So don't include -1 up to 0. Or 3 to infinity. That's where else it's positive, right? Cool. So this step obviously is crazy important. That's not enough. Right? You gotta tell me what the answer is. Okay.
Jeff, was that a homework question?
I don't know. That was number. Oh, that was from the review.
It was just for.
It was from the review, so. But you know, at least you see the process still going. Right? This process can't change. Okay. All right. So any other questions from? We got up into 9-1. We actually finished 9-1. Because we're crazy like that. Or I'm crazy like that. Did 9-1 make sense? No, shit. All right. Let's review that.
That's how much it didn't make sense.
Have you guys ever been in a class where they use the clickers? And when I say that, you guys are all like, you mean those things you use for your pets to keep them in line? No, there's like, you can poll your class and say, do you guys understand? You can hit yes or no, and then there's a graph that shows up. I would use them. I think they're really cool if only they would work all the time. Because they always have trouble with the receiver, and they have trouble with the software, and they have trouble with people. Mine's not working, neither's mine, mine's freaking. I don't want that extra crap. So it would be nice though, just to be able to say, A, B, C, D, do this problem, and then you guys do it, and then to see what percentage got it right, what percentage got it wrong, and if it's a huge percentage you got it wrong, oh shit, I better stop and focus on this. It's a really nice tool.
They had a text message. We used to do, well, we did clickers last semester, and they have a text message one for one of my classes. I think that worked better because there wasn't people like, what channel are you on?
Oh, yeah. Yeah.
You know.
I gotta look into that, so a text message thing.
It was
But then not everybody has like a,
Well, then people are like, well, I don't have text like you. But yeah, and I guess it just went to a computer system, but they would ask you in the middle of the class, like, in the class, like, how are you feeling?
yeah.
You know, like, so it was
Yeah, one of my colleagues uses like different color construction paper. The back of them is white or something, so over behind you can see it's like the front is green if you're good or red if you're bad. How's everybody doing? Red. Oh shit.
Yeah.
Alright, so 9-1. The first part of 9-1 I'm hoping you guys agree with me was basically a review really. Just making it a little more official.
Yes.
Right? Putting one function inside of another function. Right. So like if I had
Oh, that's right.
what would g of f of x be? Which actually would be written as, let me write it the way you might see in the book. In this case, it's the goff or goof function, right? Remember, you read this as g of f. So the very first thing you can do is write it in the better way. So in algebra, where do you always start in a problem? You start in the inside, right? So what is it I'm putting into G? What is F? Cube root of x minus 7. And now this is telling me to put that whole thing inside G. Right? So it's just the same. Functions can't change. They're always based on substitution. Substitute whatever's in there in place of the x. On one level, that's all they are, really. So plug that bad boy in. What's the cool thing that happens there? Yeah, the cube and the cube root cancel. So that's what g of f of x is, just that. Now, why does it make sense on one level that the answer came out so nice? What's special about those two functions? Almost perfectly, but not quite. Why did you know that was going to happen? Why did I make it the way I did? yeah, this piece, the cube root, is the inverse of a cube. Right? Now these are not inverse functions because they didn't come out, they didn't kill each other totally. Let me show you what would happen with inverse functions. If I had a function, let's see if Jeff made this correctly. So if I did g of f of x, so g of this whole mess here, I'll let you guys try to catch up there. Try to do that and see what happens. Take this and throw it in there, right? So that's G, I mean that's F, and it's inside G. How are we doing so far? So I took F, that whole thing, and put it right there, right? That's what I'm supposed to do. I gotta put that whole thing inside G. So the fifth root symbol better be there, the -2 better be there, the +3 better be there, because they all gotta be there for G. It's just that X is now replaced with this whole thing. Right?
Right.
Then what happens inside that's nice? The 2's cancel, fifth root and the fifth power cancels. You get X -3 plus 3. What do you think that means about G and F? Of course, I gave it away in the way into this problem, but see who remembers what I said. Yeah, they got to be inverses of each other. What does F do to X? That mess, right? It makes X become this mess. If G is going to be his inverse, it better take whatever he did and bring it back to X. It better undo all the shit he did, right? And does it? Yeah, whatever F did to X, G undoes it. That's kind of like a check. If they say check to make sure that these functions are inverses, put one inside the other one, it better come out to X. They better undo each other, come back to X. Because one way to look at a function is it'll take whatever you put into it and do something to it, right? That's what functions do. So the inverse function better take whatever it did to it and undo it. So it should end up with just X there. So what could I officially call G of X then? What's another symbol I could use? Because now we just proved that it's the opposite. And if you look at it, that's why I kind of designed it to be that way, right? I got a fifth power, a fifth root. -3, a +3, a +2, a -2. Right? All the operations are opposite in reverse order. Okay. So what do you think? Let me go on a less specific level here. What do you guys think this is? Whatever this function does to this, this will undo it. So I better end where I started. It's going to equal X. Isn't that what we just did?
Mm-hmm.
We put the inverse inside the other function, it came out to X. So here's a funny thing. You're going to see a lot of this kind of thing. What's G inverse of G of 2? 2. Because what do these two things do? We've been actually doing this whole time. These two things cancel, don't they? What's the inverse function of division by 2? Multiplication by 2. What do? They cancel.
X.
Right? So if G was divide by 2, and then G inverse was multiply by 2, I'd end up back to where I started. One would undo the other one. We've been doing that. We just did this here. What's the fifth root of x plus 1 to the fifth power? X plus 1, right? So what's G inverse of G of x plus 1? X plus 1. Because G could be like the fifth root, and G inverse could be like the fifth power. You guys with me? We've been doing that this whole time. It's just that this is a little more vague. It could be any function and its inverse. We know that they will kill each other. That's the whole point. A function and its inverse will die. Kill each other. Even that guy on the inside. Okay, cool. Maybe. So let's review. That's kind of like the new little thing. Last little thing I didn't talk about from section 9.1 is how to check if a function is some other function's inverse. Plug it into that and see that you get just x at the end or just whatever at the end. Okay. So coming back to a review. I love this kind of problem. In fact, I have one on the practice test. This function here. Oh, it's just straight line, Jeff. Good job. So if I have this function here, how do I graph its inverse? How do I know that an inverse exists? Exactly. Why does an inverse exist? It's 1-to-1 because it passes the horizontal line test. I mean, here's an example of, you either go to yourself and you say to yourself, shit, we have the vertical, now we got the horizontal, what's next, the diagonal line, what the freak, right? But what's really important for you as a student is to say, I understand vertical line test. I think we all do, right? Just see if it's a function. The reason that the horizontal one exists is because I would flip this over. Like you saw the parabola, it doesn't work because when I flip it over, it's not a function anymore. So instead of actually flipping the graph over, let me flip the freaking test over. So instead of looking at a vertical test, I'm going to look at a horizontal. It's the same thing. Instead of flipping the graph, I flip the test. It'll tell me the same thing. So this does pass a horizontal. Any horizontal line will only go through once. So an inverse does exist. So how do you graph its inverse then? What would you have to do?
Opposite points.
Opposite points. So this goes through the point, and this point is, which is trying to be 1, negative 2, 2, 1, 3, 3. Cool. Right? So it's not really a straight line. It just looks that way because of my scale. So what should the inverse go through then?
Negative 3, 3.
Negative 3, negative 3.
Negative 2, 1.
Negative 2, 1.
1, 2.
1, 2.
And 3, 3.
3, 3. So it's going to start here. It's going to go to negative 2, 1. 1, 2. And then 3, 3. Kind of like this. So see how they got the nice symmetry here, like you should? To me, it's one of the, I don't know. We all know I'm a geek, but I just love that you always get that nice symmetry when you do that with a function that has an inverse. Okay, so that's visually how to find an inverse. And what did we actually do? What did we really do? We took the x's and y's and we flipped them. And if you think back to what an inverse function does, it takes the output of 1 and brings it back to its input, doesn't it? This function took 2 and made it 1. So what should its opposite function do? It should take that 1 and bring it back to 2. So I know we got a lot of like little, okay, I gotta flip it, and then I gotta flip the x and the y in the equation, but always go back to why the hell does that make sense? Everything kind of feeds off. It's kind of cool. I love inverse functions because it's like the same damn thing every time, no matter. Visually, flip the x and y. Equation, flip the x and y. I mean, you can't beat that. I'm sure you could actually, but I don't. So how do you do it algebraically? How do you find the inverse of real quick, I haven't talked about this directly, but we've seen this. Side note. Any x to an even power looks like what? Like x squared, x to the fourth. Those are going to look like what? What's x squared look like? If you graph it. Parabola. So any x to an even power is going to look like this. If it's x to the 10th, it's just going to rise a lot quicker, right? Because 2 to the 10th is big. So it's going to just be a skinny one, but it's going to all be parabola. So x to any even number, are any of those one-to-one functions?
No.
Do they pass the appropriate test? No, they don't pass the horizontal line test, right? So notice I'm very careful when I do this that I put an odd power there. Because what does x to an odd power look like? It looks like a parabola where the other half fell out. Think about it. What's 2 cubed? What's 2 cubed? 8. What's negative 2 cubed? Negative 8. See, so it goes down here. So x to an odd power, does it pass our horizontal line test? Yes, it passes. That's why I can find an inverse here. If I had this question to a 6th power, you should come up and slap me. Let me see if I accidentally do that one. See who actually comes up and slaps me.
Not slap, smack you in the back of the head.
Smack me in the back of the head, whatever. I say, come on, math boy. What's my first step to do this now that we realize that an inverse does exist, so nobody has to smack me? That's my first thing to do. Because what did we do over here to find the inverse? We flip the x and y. Do I have a y?
Yes.
Yes, I do. Just let's put it back in there more explicitly there, right? And then I do like we just said. I flip the x and y. So on one level that makes sense because it's the same thing we did graphically. There really should be connection graphically and algebraically. There's got to be a connection. But on another level, once I start solving this, am I not going to undo all these operations? So sort of like this is memory. It's kind of like remembering all the stuff I'm doing to undo all this mess. So whatever's going to end up over here is going to be the opposite of whatever was here in the first place. Right? Because what do I do first? I have to subtract 7 instead of add 7, right? And then I have to, what do I do to kill that 7th power? Take a 7th root. Do I need to put a plus or minus? I didn't realize it was going to be that. No, because again, it's an odd power, odd root. They're cool with positive and negative. I don't put a plus or minus. That's the whole reason really why algebraically, like x to the 6th breaks down. Because if you tried to do it and you took the 6th root of both sides, you have to put a plus or minus. And then there isn't one function, there's actually 2 separate functions that answer this question. That's why there doesn't exist a inverse function, or grammatically correctly, an inverse function, because there actually has to be 2, a plus or minus. So here was the last step. Subtract 2 on both sides, right? So f inverse would be this mess. So instead of adding and adding, I subtract and subtract. Instead of raising to a 7th power, I take the 7th root. So it makes sense that they're inverses. How would you check that you did this correctly? You would do it again. No, how would you check? You would take this guy and put it into the other guy. And you better get what at the end? X. That's a quick check. Well, not the quickest, but You could also graph it, but the thing to realize about your calculator, I think I talked about this before, if you graph a circle on your calculator, which if we had time in 10, we would, I probably will at some point, it would look like a football because it's not a square, it's a rectangle. So kind of like it doesn't give me good symmetric shapes. Do you see what I'm saying? There's actually a way you can make it square, but it's... So if I try to graph this, it won't look like this. It'll be kind of like skewed a bit, so it's really hard to see that symmetry. Okay, maybe. Blah, 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 blah. So any other specific questions from 9.1? Look on page 711, number... let's see. Number 24. And it gives you a table of values. Yeah, what's up?
What does that say in the parentheses in the first one?
Who can tell me what that
Y2
says?
of Y1.
Yeah,
Oh.
y2 of y1. Right. Let me see if we can cut off Chase a little bit here. So it gives you a bunch of values. I'm just going to pick off the, well, there might be more than that since it's relevant. But so it gives you a bunch of values here. Real quick, let me see. This is sort of a separate side issue. Can you guys look at y1? That's a function. It takes these inputs and these are the outputs. Can you see sort of what this is built on? What does it keep doing?
Adding.
So added 3 should show up in the function somewhere, right? So it should be a plus 3 somewhere, right? Or at least 3 times something. Because I can see kind of like the y-intercept there, and it should be like it's actually going to end up being 3x plus 5. Because it keeps going up by 3 every time x goes up by 1, the y's go up by 3. Look at this, so y2. Can somebody tell me what does that look like? It starts at 1, it goes down to -3, and then it goes back up. Parabola, beautiful, right? You can actually see the vertex because it's symmetric on both sides. Do you guys see that? Do you have to be able to do that? No. But it should be kind of like something that's coming off everything else we're doing. So how the hell do I do that? What does that really say? And somebody just told me what it says, right? y2 of y1 of -1. So what do I do first? Yeah, start from the inside, as always. So what's y1 of -1?
Do you pick a number from the middle?
You don't pick any number.
Oh, okay.
What is y1 of -1? So the input has to be
-1.
-1. And what does y1 get for an answer? 2. You guys see that? For an input of -1, what does y1 give me? 2. That's all that's asking, isn't it? It says what's y1 when the input's -1. Alright, the input's -1, what's y1? 2. And then, so now I can replace this whole thing with 2. And now it's asking me, okay, what's y2 of 2?
-3.
So for an input of 2, y2 is 6. So see, it's not, what am I putting into y2? I'm putting this. So of course, what I have to do first, I have to figure out what the hell this is before I can go put something into y2. What am I putting into y2? Something I don't know yet. Well, now I know what the hell it is. So when the input's 2, y2 is 6. Cool. So this is funny because this is less work than normal. Normally they're going to give me an F and a G and I've actually got to plug stuff in and get it. This is quicker. Somebody's already done the freaking work. They listed all their answers here.
Good.
That's why they didn't give me a function, because they've already done the work. So when they plug a -1 in, what must they've gotten out? A 2. When they plugged a 2 into that guy, they must have got a 6 out, because I can see it. Yeah. Oh. Do you remember this problem here from before? And this gave us a lot of trouble, but I think I got to the point where most everybody understood what's going on. Let me find out if you guys remember. Let's make a little tiny function here. Okay. So this is the function f. So what is f of 1?
One.
Zero?
Ooh.
2.
Oh, I'm sorry.
Yeah, it's 2.
Two.
How do you know? You don't have a function to plug 1 into. Why do you not need something to plug into? Somebody already did. What must they have gotten out for 1 because of where they put the point? They must have got a 2 out because they put the point at 1, 2. Right? Do you remember this? We did this kind of problem before. Yeah. And this is really freaky when you first see it because you're so used to having that safety net of the function to actually get your teeth into and look at. This is even nicer though. Somebody's already done the work. This is nicer. What's f of 2?
0.
0.
Zero.
What's f of the only other one I made definite? -2.
1.
-1. So, did I really have to give this picture to you? Couldn't I have given it to you like this? Okay. What's f of 2? 0, because that's, so, same thing. What's y1 of -3? -4, that's the output there, right? Is that cool?
So where'd you get the 6?
Okay.
That's the other thing I'm confused.
That's what y2 is, right? And at this level, so right here it says, what's y1 when the input's -1? So that's right there. Now what does this say? If I replace that with 2, what is this asking me now? What is y2 when the input is
Okay.
2?
Okay. So
When the
then.
input's 2?
Okay. Okay.
Cool.
So it's like building, like getting close to the answer, because it's inside, find that answer.
Just like we do, if I had 3 minus 4 minus 7 minus 8, what would you do first?
7 minus 8.
Yeah. So I like the way that Kevin just said, it's like getting closer to the answer. You're working away from the inside out.
Okay.
What are we doing here? Inside out. Right? Same thing we always do. Because you got to know what the hell the inside is before you can do the shit on the outside.
Mm-hmm.
It says, it's this of something. Oh shit, well what's that? Okay, it's 2. Now I can do that. Alright. So it's all a question of, it is simple, it's just a freaky way of looking at it that you're not used to. So something that's got to kind of click, you know, oh, that's all it's doing, right? I don't have to have a function to already see the answers. If I plugged in 1 into whatever the hell this is, I would get a 2. I see it, I don't have to do it.
It's confusing to look at when they throw the F instead of just saying X is 2, what would Y be, you know what I mean?
I got you. But this is sort of shorthand way of saying that. And of course, math people, we love that. We love short ways of saying something.
Confusing.
That's one reason why math is more difficult, but our papers are smaller than English papers. Yeah, it's a trade-off. Okay.
It's your own secret language.
Yeah.
Break. Break.
Huh?
Break.
I'll tell you this. I've got a conference today that starts at like 12, which is awesome. So I've got to head out early anyway. All I want to do is 9-2 and 9-3. We can certainly take like a little break. We can take like a 10-minute break maybe.
That's okay.
Come back at 5 after.
Yeah, okay.
Okay.